are actually secure against any kind of more clever attacks. It might be that the transformation process has a problem. It might be that we are counting how many soap bodies there are. Then it might look like it's covered, but even though changes are possible. It does not check for or try to find exploits in the signature verification process. And even though it flips things and does that in a deterministic and controlled way, it's not a fuzzer in that case. But what does it do? It can detect, and very simplistic and easily detect, the absence of any integrity protection. So basically white spots where the signature is not offering any protection at all. It works the way we designed it independently of the signature verification process, so it treats that as a complete black box. It's implemented on the application level, so you do use the same parser logic to select the flipping data, and the application is in full control. And with the evil homer, it would be enough to flip a single bit or a single character to detect that there in this string there is something not protected. So we can basically assume if this is the name on a purchase order, then not only this one character of the name was not signed, but the whole name that we as an application are working with is not covered. So the overhead for this would be for one field of data or one blob of data that the application wants to be secured, would be the overhead of one additional signature verification. To conclude, so BitFlip allows applications to test if a signature verification process covers the data. And it does that in a way that it involves the application logic or uses the same extraction mechanism as the application logic. It's not a different policy language you have to do as an application programmer. It's not some verification rules you have to give to your verification process. It can all be done in the same application logic. It does this, as I said, in a black box process. If you do opt not to do this in a black box way and have a granular output, then you might not even need to go as far as running an RSA signature verification. You might just do, okay, apply the same transformations, apply this extraction, give me the hash, and if the hashes do not match, then I don't have to do a signature verification, which is the most costly thing here. So you might end up being even quicker to evaluate that something is not protected. And it can be used in general as a tool if you do not deploy it and run it every time an application works on some data. You might run it as a testing tool to see if either the layers that you build on top, if you roll out a new application, are fit for this application. You can rerun these as tests when you have done any changes, applied any updates to your policies, or just detect some errors in the verification process, because it's quite visually appealing if you see that something is red and something is green, and if you then talk to the developer and they say, yeah, but we rely on this data down here, why is this data now red? Then you can say, yeah, because it's not covered. So that's it. Any questions?
Something about the absence of data, or you at least have it on
the absence of integrity protection, yeah.
But can you
Oh, the question is, can you detect absence of data? So basically, your question is you insert
a character, for instance, or you insert a parameter or something somewhere. Instead of just flipping out.
That might deal, if I understood the question correctly, that might deal with a different form of attack or a different problem, because the problem what I was looking at was, okay, I have some information that has been extracted from the message. I'm the application. Now I want to do something that might really cost me money if this was not protected. So how do I can, at this point in time, make sure that it was sufficiently covered under the verification that has been done to the verification process. The attack of inserting something that has not been there before is what the wrapping does. They insert something, they move something away, and they insert something that was not there before, but in a position where the application now works with it. If you add something to a signed XML document which is not covered by the signature, which is the idea of being not covered by the signature, then you can actually add whatever you want at the positions where it has not been selected to be signed. Was I too quick? Oh, yes.
Your technique is meant to be applied to all the fields that are important to the message, or is enough to check on one of the many? Because then it might increase the computational load.
The question is, do you have to do this on every field that is important to question? Because if you do, that might introduce an overhead and computational overhead. Yes, you have to repeat that on all the information that your application wants to be reassured on. And yes, it might be computational overhead. And the better way, the real way to mitigate these threats is to have in your verification process the policy to have the stream verification processes that can work on XML streams, and they can streams and they throw away a message once it does not comply to any of your policies. But for some reason or another, they do not see the real life everywhere yet, these validation processes.
How about using it for unit testing during development?
Yes, would be. Well, the problem with unit testing is that you can't test for attacks, which you don't know. So unit testing, yes, you would have a message which you think is the one that usually comes into your system, and then you run this flipping, and then you see, okay, is this message protected in the way we want it? The wrapping attacks most likely will not, I mean, now we know them. Now we know how they would work, and we can come up with clever examples, but you can't do unit tests in a clever way to overpower all the unknown adversaries that your application might have. So basically you can't test enough, but you can use it for unit testing. as I said, in the development phase, you could use that as a tool to aid. Okay, thank you very much.